In this problem, I'd like to use dimensional analysis to determine whether or not an order is safe. We are told that a child is ordered inasin 800 milligrams every 4 hours and that the child weighs 33 pounds. The recommended dose is between 100 to 200 milligrams per kilogram per day or 200 to 400 milligrams per kilogram per day for severe infections. We need to determine whether or not this is appropriate for this child. In all of these problems, we are looking to compare the order to what's recommended. And the trouble is that the order and the recommended amounts are in different units. So our goal in all of these problems in a dose safety check problem is to convert the order or the recommended so that the units match. Now let's look at the units that we're given. We're told that the order is 800 milligrams. And this is 800 milligrams every 4 hours. So that's telling us the patient would receive 800 milligrams every single dose. The every 4 hours is telling us if there's every 4 hours, that means if we take 24 and divide it by 4, that means the patient would receive 6 doses. So we would have 800 milligrams per dose, and every 4 hours indicates there would be a total of 6 doses. The recommended is actually a little bit more complicated than other problems in that we're given two recommended ranges. One is 100 to 200 milligrams per kilogram per day, and the other is 200 to 400. That means what we're going to consider is anything between 100 milligrams per kilogram per day all the way up to 400, depending on the information here. And we're not given any other information about this patient, whether or not they are being treated for a severe infection or not. So what we're going to be considering here is anything from 100 up to 400. So that's the minimum that would be appropriate, 100 milligrams for every kilogram per day, and the max will be 400. Now again, the problem is that these two units don't match. We have 800, and if you were to right now say 800 is not in that range, therefore it's not safe, that wouldn't be accurate. And the reason why is because the order is in milligrams per dose. This is in milligrams per kilogram per day. Well, one thing we need to do, it should be obvious, is that this per kilogram is getting in the way. We know the patient should receive 100 milligrams for every single kilogram that they weigh. So what we need to do is to determine how many kilograms does this patient weigh. Up above, we know that the patient weighs 33 pounds. So the first step, and in most of these problems this is usually the first step, is to determine how many kilograms the patient weighs, converting pounds into kilograms using dimensional analysis. So I know pounds would cancel because I have the conversion factor. Pounds is going to be in the denominator. And I know the conversion factor is 2.2 pounds equals 1 kilogram. So if you were to divide 33 by 2.2, you would get 15 kilograms. So this patient weighs 15 kilograms. That's important because now it allows us to cancel out this unit of kilograms. If we know that this patient is supposed to receive 100 milligrams per kilogram, we can write this in a dimensional analysis approach, looking first at the minimum range, 100 milligrams per kilogram, and this is per day. We can eliminate this per kilogram by multiplying by the patient's weight of 15. Multiplying for every one of those 15 kilograms, they're receiving 100 milligrams. That would be a total of 1,500, and the unit remaining would be milligrams per day. That's the minimum recommended dose. We'll repeat the same procedure for the maximum recommended dose. Keeping in mind here, the goal in all of these problems, once again, is to get the units of the order and the recommended to match. So I'm multiplying by 15 kilograms, and you will get 6,000. 6,000, and once again, the unit will be milligrams per day. So our recommended range for a child weighing 33 pounds would be somewhere between 1,500 milligrams per day all the way up to 6,000 milligrams per day. That would be the recommended range. If you were to look over here at the order, we see 800 milligrams. It would be incorrect to say, since 800 milligrams is less than the range, therefore, or since it's less than the range, we would conclude that it's not safe. The reason we can't jump to that conclusion is, again, because the units don't match. The order is given to us as milligrams per dose. The recommended range right now is milligrams per day. I can, looking at the order, use the information provided if it's 800 milligrams per dose, and I know throughout the day the patient's going to receive 6 doses, then I can take 800 milligrams per dose and I can multiply by the number of doses. I know there are 6 doses in one day. And what will happen is I will convert this. This will turn into, this will be 4,800 and the unit will be milligrams per day. The big picture, you are trying to get the units to match on the order and on the recommended range. And we see that since the order is 4,800 milligrams per day, and that is contained within the recommended range, it's a little closer to the maximum, but it's certainly within those two numbers, we would conclude yes. Yes, this order would be appropriate for this child because it is contained, once after we convert, it is contained within the recommended range.